Okay, so today we are starting what digits has marked as topics 5 and 8. Because I'm kind of veering away from the order that digits does it, I'm not calling it 5.1 or 8.1. I'm just having them called day 1 and day 2 and day 3, so on and so forth. So today's objective is I can represent a proportional relationship in a variety of ways. Last year is when we actually learned about proportional relationships. I think that was when I was gone, so you may not remember that. So we're just going to review what a proportional relationship is. So a proportional relationship is a relationship between two equal ratios. Okay, so basically what you're looking for is that one quantity is always a constant multiple of the other. Now, there's 3 different ways that you can represent a proportional relationship, and your foldable that you have has those. It's tables, graphs, and equations, and we'll fold those down eventually. You'll cut them so that it makes little flaps, but I'm just going to go ahead and write on here. So this is for tables. This is tables, okay? So what you're looking for to determine if it's a proportional relationship is basically the same thing as the definition, that one quantity is a constant multiple, if I can spell, multiple of the other quantity. And hopefully we all remember what a multiple is, but if you don't, okay, a multiple is the result of multiplying a number by an integer. So like if I start at 2, the next multiple of 2 is 4, because I multiply 2 by 2 to get 4. 2 times 3 is 6. 2 times 4 is 8, so on and so forth. Okay, so those are the multiples of 2. Okay, so if you look down here at this graph, this is an example of a proportional relationship because y is always 2 times x. Okay, so if I multiply 0 times 2, I get 0. If I multiply 1 times 2, I get 2. 2 times 2 is 4. 3 times 2 is 6. Okay, and I'll give you a name for this right in a little bit. Okay, but that's what you're looking for in a table. Okay, when you're looking at a graph, there's 2 different things that you look for. You're looking for a straight line. Okay, and it also has to pass through the origin, which the origin, does anybody know the coordinates of the origin? It's 0, 0. Okay, so the origin is right there, so this one passes through the origin. Okay, and it is a straight line. Okay, so now we're moving on to equations. So when we have an equation, we're looking for equations in the form y equals mx, okay, where m is the constant of proportionality, or that y divided by x, which if you look back here, if I do y divided by x, so if I do 2 divided by 1, I get 2, which is that same all the way down. 4 divided by 2 is 2. 6 divided by 3 is 2. Now 0, 0 obviously isn't going to give me 2, but that's that origin that we have to pass through. Okay. So this is my constant multiple. That y over x is my constant multiple that I identified on my table over here, that 2. Okay. Now, eventually, we will call m slope. Okay. and we'll have a little bit different equation, but we'll get to that on a different day. So down here in my equation, that 2 is my constant of proportionality. Okay. So now we're going to do some practice identifying if a relationship is proportional or not. So we're going to use those qualifications that we wrote on our foldable to decide. Okay, so we're looking at a graph, so I'm looking at this first one, or it's the middle one. So first I have to decide, is it a straight line? Well, yes, it's a straight line. Okay, then I have to decide, does it pass through the origin? Well, if I look, here's 0, 0, and it doesn't go through there, so that's no. Okay, because it does not pass through the origin. Okay. Okay, now I'm moving on to this equation. Okay, y equals 2x. Well, that looks exactly like this one. Okay, it's in that form y equals mx, so that one is yes. Okay, I can't have anything after it. It's got to be all by itself. Okay, and then I'm looking here and I'm deciding is everything a constant multiple? Now, if I were to go backwards, okay, like see how this increases by 5 each time? Okay, if I were to go this way, okay, and I were to say, if I go down 5, this would be 0. This increases by 2 each time. Okay. So if I go down 2, I get to 0. So there's my 0, 0. Okay, I can multiply 2 by 2.5, and that gives me 5. If I multiply 4 times 2.5, that gives me 10. And if I multiply 6 by 2.5, that gives me 15. So this is also yes. Okay, you can also check that by just doing the y over the x, which would be 2 over 5, 4 over 10 simplifies to 2 over 5, and 6 over 15 also simplifies to 2 over 5. So that is yes. Okay, go ahead and do the U try.